विद्यार्थियों, आज दी फिजिक्स प्रैक्टिकल क्लास विच तुहाडा स्वागत है। आज दी क्लास विच असीं दो एक्सपैरीमेंट्स दे बारे गल करांगे जिन्हां दे नां हन स्पैसिफिक रेजिस्टेंस ऑफ अ वायर अते वेरीफाई द लॉज ऑफ कॉम्बिनेशन ऑफ रेजिस्टेंस। First of all, let us find out the specific resistance of a wire using meter bridge, and the objective of the experiment is to find resistance of a given wire using a meter bridge and hence determine the specific resistance of its material.
Apparatus required for the experiment are meter bridge, battery eliminator, jockey, one-way key, resistance box, a galvanometer, metal wire as resistance wire, screw gauge, and connecting wires. This is the circuit diagram for this experiment. It consists of a wire of constant 10 or manganese of length 1 meter and having uniform area of cross section. It is stretched between the thick copper strips on a horizontal wooden board. A meter scale is also fitted on the wooden board, parallel to the length of the wire. There is another copper strip fitted on the wooden board in order to provide two gaps in strips. Across one gap, a resistance box providing resistance, say R, and in another gap, the unknown resistance X are connected. One terminal of a galvanometer is connected to the jockey and the other to terminal D. The positive pole of the battery is connected to terminal A and the negative pole of the battery to the terminal C through a one-way key K.
Working of a meter bridge or slide wire bridge is based on Wheatstone bridge. Let us discuss the theory of meter bridge.
When any one key of resistance box is open and the key K is closed, current I passes through the 1 meter wire only when the jockey is in contact with the wire and the galvanometer shows some deflection. But on adjusting the position of the jockey, deflection of galvanometer varies and at a certain position, galvanometer shows no deflection. This is the balanced condition. Let an unknown resistance X be connected across the right-hand gap and a resistance box across the left-hand gap of the meter bridge. A secondary cell of EMF E and a galvanometer G are also connected across AC and BD respectively. Let the balance point be obtained at the position B on the wire. In the balanced condition from the Wheatstone bridge principle, we have P upon Q equal to R upon X, where P and Q are the resistances of the portions AB and BC of the wire respectively. If the wire of the meter bridge is of uniform area cross-section, then the resistance of AB is proportional to the length of AB, and resistance of BC is proportional to the length of BC. If AB is equal to L, then BC would be equal to 100 minus L, as length of wire is 100 centimeter. Since R and L are known, hence unknown resistance of the given wire can be easily determined as L upon 100 minus L is equal to R upon X, or X is equal to R into 100 minus L upon L. Let ρ be the specific resistance of the given wire of resistance X, L be its length, and D be its diameter. Then resistance X would be equal to ρ into 4L upon pi d square. That is, specific resistance ρ would be equal to X into pi d square upon 4L.
On substituting the values of X, L and D, specific resistance ρ of the material of the given wire can be calculated. Procedure for the measurement of X and D is: resistance box ਤੋਂ ਕੁਝ resistances ਬਾਹਰ ਕੱਢੋ ਅਤੇ one way key K ਨੂੰ ਪਲੱਗ ਕਰੋ। ਹੁਣ ਸਰਕਟ ਦੀ ਕਰੈਕਟਨੈਸ ਨੂੰ ਚੈੱਕ ਕਰਨ ਲਈ ਬ੍ਰਿਜ ਵਾਇਰ ਦੇ ਪਹਿਲਾਂ ਲੈਫਟ ਅਤੇ ਫਿਰ ਰਾਈਟ ਐਂਡ ਤੇ ਜੌਕੀ ਨੂੰ ਆਰਾਮ ਨਾਲ ਟੱਚ ਕਰੋ। ਗੈਲਵਾਨੋਮੀਟਰ ਵਿੱਚ ਡਿਫਲੈਕਸ਼ਨਸ ਨੂੰ ਨੋਟ ਕਰੋ। ਜੇ ਗੈਲਵਾਨੋਮੀਟਰ opposite directions ਵਿੱਚ deflections show ਕਰਦਾ ਹੈ ਤਾਂ connections correct ਹਨ। To find out the resistance of the given wire, slide the jockey gently along the wire from left to right till galvanometer gives no deflection. The point where jockey is touching the wire is null point. Note down the position of the null point to know the balancing length L. From the position of the null point, write down the values for L and 100 minus L in the observation table. In the same way, we can find out another set of null points for different values of R. After obtaining the balance position, the resistance box and the unknown resistance should be interchanged, and the no deflection position should be obtained again. This way, the index error becomes ineffective.
Record the observations in the observation table. Here, the main value of unknown resistance is 1.82 ohm. Now, remove the resistance wire, stretch it and find its length between the two terminals. Here, it is 33.5 centimeter. Measure the diameter of the wire using screw gauge. First of all, we determine the least count of the screw gauge. To find the least count, give one complete rotation to the screw and the distance moved by the screw on the linear scale is equal to the pitch of the screw gauge. Here, pitch is equal to 0.5 millimeter. Circumference of the circular cap is divided into 100 divisions. That is, number of divisions on circular scale is 100. Hence, the least count of the screw gauge is 0.005 millimeter or 0.0005 centimeter. We know that due to wear and tear in the instrument, the zero mark of the circular scale does not coincide with the zero of the pitch scale. Then the instrument is said to have a zero error. To find the zero error, rotate the screw forward till the spindle face of the screw touches the anvil face of the screw gauge and edge of the circular cap comes on the zero mark of the linear scale. Here, zero mark of the circular scale coincides with the reference line. Therefore, there is no zero error. Since the zero error in the screw gauge is nil, hence there is no zero correction. To find the diameter of the wire, place the wire over the anvil face and rotate the screw using the ratchet head towards the anvil face and stop when ratchet slips without moving the screw. Note the number of the division of the linear scale visible and uncovered by the edge of the cap as linear scale reading. It is 0 millimeters. Note the number of the division of the circular scale lying above the reference line. Here it is the 66th division of circular scale. Record the values of linear scale and circular scale and calculate the screw gauge reading. Here, the value of the diameter of the wire D is 0.0 plus 66 into 0.005, that is 0.33 millimeters. Therefore, the diameter of the given wire D is 0.33 millimeters or 0.033 centimeter.
Here are the calculations required to find out the specific resistance. First, we calculate the mean value of unknown resistance. Here it is 1.82 ohm. Similarly, the mean corrected diameter is 0.33 millimeter or 33 into 10 raised to the power minus 5 meter. In this experiment, the specific resistance of the material of the wire rho is equal to 1.82 into 3.14 into square of 33 into 10 raised to the power minus 5 upon 4 into 33.5 into 10 raised to the power minus 2, which is equal to 46.44 into 10 raised to the power minus 8 ohm meter. Whereas the standard value of the specific resistance of the material of the wire rho 0 is 49 into 10 raised to the power minus 8 ohm meter. Hence, percentage error in the value of the specific resistance of the material of the wire is of 5.2%. Result: the value of the unknown resistance is 1.82 ohm. The specific resistance of the material of the given wire is 46.44 into 10 raised to the power minus 8 ohm meter. Percentage error is 5.2%. Let us now verify the laws of combination of resistance using meter bridge. Objective of the experiment is to verify the laws of series and parallel combination of resistances using a meter bridge. Apparatus required for the experiment are
meter bridge, metal wire as resistance wires, battery eliminator, jockey, resistance box, a galvanometer, one-way key, and connecting wires. This is the circuit diagram for this experiment. It is similar to our previous experiment, only the difference is in the right gap in place of single resistance wire, we have used the series and parallel combination of resistance wires.
Theory. Of course, the working principle of this experiment is based on meter bridge. That is, the unknown resistance of the given wire can be determined as X equal to R into 100 minus L upon L, where L is the length of the wire at which meter bridge is balanced. But here, we also require the expressions for the series and parallel combinations of the resistances. So, let us discuss the relation for series and parallel combination of resistances.
Series combination of resistances. Resistors are said to be connected in series if the same current is flowing through each resistor when some potential difference is applied across the combination. If the three resistances R1, R2 and R3 are connected as shown in this figure, they are said to be connected in series. If V is the potential difference applied across the combination of these three resistors using the battery, in series combination, the same current, say I, will be passing through each resistance. Let V1, V2 and V3 be the potential difference across R1, R2 and R3 respectively. Then, according to the Ohm's law, V1 is equal to I into R1, V2 is equal to I into R2, and V3 is equal to I into R3. Here, V is equal to V1 plus V2 plus V3. If Rs be the equivalent resistance of the given series combination of resistances, then the potential difference across the combination is given as V equal to I into Rs. In other words, IRs is equal to IR1 plus IR2 plus IR3, or Rs is equal to R1 plus R2 plus R3. Let us now analyze the parallel combination of resistances. Resistors are said to be connected in parallel if potential difference across each of them is the same and is equal to the applied potential difference. If the three resistances R1, R2 and R3 are connected as shown in this figure, they are said to be connected in parallel. If V is the potential difference applied across the combination of these three resistors using the battery, let I1, I2 and I3 be the current passing through resistors R1, R2 and R3 respectively. Then, according to the Ohm's law, I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V upon R3. Here I is equal to I1 plus I2 plus I3. If Rp be the equivalent resistance of the given parallel combination of resistances, then the potential difference across the combination is given as V equal to I into Rp. In other words, V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3, or 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3.
Procedure. To verify the law of combination of resistances, first of all, we have to measure the individual resistances as in our previous experiment. Then, repeat the experiment for each combination of resistances.
Connect the resistance wire whose resistance is to be determined in the right gap. Connect resistance box of low range in the left hand gap. Make all other connections as per the circuit diagram. Take out some resistance from the resistance box and plug the one-way key K. Touch the jockey gently first at left and then at right end of the bridge wire to check the correctness of the circuit. Note the deflections in the galvanometer. If the galvanometer shows deflections in opposite directions, the connections are correct. To find out the resistance of the given wire, slide the jockey gently along the wire from left to right till galvanometer gives no deflection. The point where jockey is touching the wire is null point. Note down the position of the null point to know the balancing length L. In the same way, find out another set of null points for different values of R1. Record the observations in the observation table and calculate the mean value of the given resistance. Here it is 2.64 ohm. Remove the resistance wire and repeat the activity for another resistance wire. Record the observations in the observation table and calculate the mean value of the given resistance. Here it is 1.82 ohm. Now connect the two wires in series combination and connect them in the right gap of meter bridge and find the resistance of this combination in similar way. Record the observations in the observation table and calculate the mean value of the given combination of the resistances. Here it is 3.97 ohm. Connect the resistance wires in parallel combination and connect them in the right gap of meter bridge and find the resistance of the combination. Record the observations in the observation table and calculate the mean value of the given combination of the resistances. Here it is 1.02 ohm.
Here are the calculations required to calculate the theoretical or the mathematical values of RS and RP. Experimental value of series combination of resistances is 3.97 ohms, whereas the theoretical value of series combination of resistances is 4.46 ohms. It is clear that the difference between the two values is of 0.49 ohm. Similarly, experimental value of parallel combination of resistances is 1.02 ohm and the theoretical value of parallel combination of resistances is 1.07 ohm. Difference between the two values is of 0.05 ohm. Result: within the limits of experimental error, experimental and theoretical values of RS are same. Hence, law of resistances in series is verified. Within the limits of experimental error, experimental and theoretical values of RP are same. Hence, law of resistances in parallel is verified. During these experiments, following precautions should be incorporated. All connections should be neat, clean and tight. As far as possible, the balance point should be confined to the middle region of the wire. In the resistance box, the plugs must be tight. The jockey should not touch the wire when it is moved to and fro. Balance position ਨੂੰ obtain ਕਰਨ ਤੋਂ ਬਾਅਦ resistance box ਅਤੇ unknown resistance ਨੂੰ interchange ਕੀਤਾ ਜਾਣਾ ਚਾਹੀਦਾ ਹੈ ਅਤੇ no deflection position ਨੂੰ ਦੁਬਾਰਾ obtain ਕਰਨਾ ਚਾਹੀਦਾ ਹੈ। ਇਸ ਤਰੀਕੇ ਨਾਲ index error ineffective ਹੋ ਜਾਵੇਗੀ। एक्सपेरिमेंटल वायर ਦੀ ਸਿਰਫ ਉਸ ਲੈਂਥ ਨੂੰ ਹੀ ਮੈਜ਼ਰ ਕਰੋ ਜਿਹੜੀ ਕਿ ਬਾਈਂਡਿੰਗ ਟਰਮੀਨਲਸ ਦੇ ਆਊਟਸਾਈਡ ਹੈ। ਸੈੱਲ ਸਰਕਟ ਦੇ ਵਿੱਚ ਕੀ ਨੂੰ ਪਹਿਲਾਂ ਬੰਦ ਹੋਣਾ ਚਾਹੀਦਾ ਹੈ ਅਤੇ ਸਿਰਫ ਉਦੋਂ ਹੀ ਜੌਕੀ ਨੂੰ ਪ੍ਰੈਸ ਕੀਤਾ ਜਾਣਾ ਚਾਹੀਦਾ ਹੈ ਤਾਂ ਕਿ ਗੈਲਵੈਨੋਮੀਟਰ ਇੰਡਿਊਸਡ EMF ਦੇ ਕਾਰਨ ਡਿਫਲੈਕਸ਼ਨ ਸ਼ੋ ਨਾ ਕਰੇ। ਪਰ ਜਦੋਂ ਕਰੰਟ ਨੂੰ ਬ੍ਰੇਕ ਕੀਤਾ ਜਾਵੇ ਤਾਂ ਰਿਵਰਸ ਸ਼ੁੱਡ ਬੀ ਡਨ। ਬੈਟਰੀ ਦੀ ਕੀ K ਨੂੰ ਸਿਰਫ ਉਦੋਂ ਹੀ ਬੰਦ ਕਰੋ ਜਦੋਂ ਰੀਡਿੰਗ ਲਈ ਜਾ ਰਹੀ ਹੋਵੇ ਅਤੇ ਹੀਟਿੰਗ ਦੁਆਰਾ ਰੈਜ਼ਿਸਟੈਂਸ ਵਿੱਚ ਚੇਂਜ ਦੇ ਕਾਰਨ एरर ਨੂੰ ਮਿਨੀਮਾਈਜ਼ ਕਰਨ ਲਈ ਇਸ ਨੂੰ ਤੁਰੰਤ ਓਪਨ ਕਰ ਦਿਓ। बैलेंस पॉइंट ਨੂੰ ਲੱਭਦੇ ਸਮੇਂ ਜੌਕੀ ਨੂੰ बहुत ਜ਼ੋਰ ਨਾਲ ਪ੍ਰੈਸ नहीं करना चाहिए, नहीं ਤਾਂ वायर ਦੀ यूनिफॉर्मिटी इफेक्ट होवेगी। So now we come to the end of today's topic. Here is a quick test for you. The first question is, what is the law of resistances in series? The answer says equivalent resistance is equal to the algebraic sum of individual resistors. Another question, what is the law of resistances in parallel? The answer, reciprocal of the equivalent resistance is equal to the sum of the reciprocals of individual resistors. Look at one more question. On what factors does the EMF of a cell depend? Answer to this question, it depends upon the temperature and concentration of the electrolyte. विद्यार्थियों, मैनू उम्मीद है कि आज दे पाठ विच दसे गए एक्सपेरिमेंट्स तुहानू काफ़ी इंटरेस्टिंग लगे होंगे। ध्यान देण लई धन्नवाद।